purpose of this JPA, Java Persistence API, is to be able to take our data that is managed in entities and push it to some database. So to do this, you have two choices. Either you use JDBC, which you have seen in 351, but you will be doing a lot of work yourself. And especially, as I explained last time, you will get a result set, and you have to convert it yourself to objects. If you want to insert, you construct string, insert statement. If you want to update, it's not very elegant. Not many people want to do it. It's nothing creative in there. It's just very repetitive. Any little mistake, your queries will not work, and so on. So that's why people had enough, and then they invented this thing called JPA. But JPA, most likely, I will take also next Sunday just to give you the kind of a bit of theory behind it. But just this JPA is really part of a bigger family called object relational mapping. So the idea is we take entities in our object-oriented programming and map them to tables in the database, and then put some middleware, some kind of pre-written software to help us shift or ship the information back and forth from our object to database and vice versa. So the object relational mapping is a concept implemented in Java using JPA. So in Java, it's very innovative. I mean, it took a lot of time, a lot of attempts to come up with this very, very elegant solution. And I hope you kind of appreciate it, is that you first take a class, which is an entity, and I explained what an entity is, and just add some simple annotations to them. This is the class. If you want to map it to a table, you add this annotation, add entity. And then you mark which attributes act as the primary key. That's it. This is the basic minimal annotation to get you started. But in many cases, as you might appreciate it maybe in your database course, or even in our course, most of the time the ID is auto-generated. The user does not enter it. So if you want to delegate this auto-generation to the database, you basically add this annotation, generated value, okay? And you say strategy is identity. Don't worry too much about it, just copy paste it. What it means is just asking the database to make this column auto-incremented. Whenever you insert a new record, it increments the ID by 1. That's it. This is the minimal to get you off the ground working. Now, once you do this simple annotation, you get a lot of fruits immediately. The first one, database can be auto-created from the classes. You don't need to create a database. Now, you need to supply certain parameters for the system to know where is the database server, what is the username, what is the password. You can do this in a simple configuration file called, in our case, called Glassfish Resources. Now, to get you started, I placed in the examples, there is a COM project, a folder called COM, and that one is fully working, and it works for a course. And you can extend it for the other ones. Now, for you to really make an impact and move very, very quickly, so try by Thursday to complete homework 3. Assignments, last lab. You know the last lab you did the entities? You did one entity, I guess, but you need to continue. Okay, so if you are there, then adding these annotations and getting it up and running is not that challenging. You will see. Okay, so that's the good news, is that once you do this, the database gets generated automatically. Now, the other way around is also feasible. If you happen to have a database, you can generate the classes from it very, very easily. So just to show you, we will not do this in our case. So just to quickly show you, if you say new, one of the things here is entity classes from a database. Okay, you go there. It discovers this is your database connection, and these I have only one class, one table. So I go here, go there, and finish. Next and finish. It will generate the class with the annotations, or with all the annotations for you. Okay. So it works very well either from class to database or database to class. And the mapping gives you all of this. Now, so that's the first fruit, is to be able to generate database from classes or vice versa. The other next thing is that you have a much better API to read and write from the database. And this API is available through this class called Entitymanager. So being in a luxurious container or a server in which your application runs, you don't need to even create such class yourself. You just declare it, declare that you want to use an entity manager, and add this annotation persistence context. Now you need to be patient with these annotations because they have designed it, they selected those names. They might not be very intuitive and very meaningful, but they are meaningful, but you need to go deeper to understand why they call it this way. But it's fine. For now, just bear with it and just be familiar with the idea and just use it mechanically until such time it clicks and you understand it a little bit deeper. So basically, once you take your entities, add the annotations, when you run your application, it will create the database. Okay? Now, if you want to read and write, you use the entity manager, and you just declare it and add this annotation on top of it. And then you need to know very simple methods that the entity manager provides. These methods I kind of quickly shown you last time. I just reviewed them quickly. If you want to look up something by ID, you use the method find. And here you provide what is the class you want to cast the result into. So I want the JPA, when it gets the course, to convert it to an object of type course class. Okay, and this is the ID. So find only works for ID. It doesn't work if you want to look up using other columns. If you want to look up or search or select using other columns, what do you need to do? Yes, you have to create a query yourself.
We create the class and we create the database.
Yeah.
Database.
Okay, very good. So in here, have a look at this.
Yes.
In here, I'm just creating some test objects. And this is not related to JPA. This is related to Java EE. In a class, you can add this annotation called post construct. And this method will be automatically executed after the object is created. So when the repository is created, I go ahead and create two objects, just two objects with through the constructor, and then I'm doing calling the add, and that's it. This will add two courses for me to get to start. No, this is not very good. No, we have to read from the file. I'll fix this one because this one I just to show you, but that part you already did before. Yeah. Yes, you go through the array and call the add for each object. Yes, that's it. Yeah. But you do, if you really want to make it more realistic, just do a small test here to say if it's already populated, you don't want to do it again. Okay? Although all of this is configurable, let me just show you one little configuration because it might create some problems for you. All right, sorry, just a second. Yep. There is a lot. This is very deep, by the way. And we are just kind of introducing ourselves to this big elephant and just using enough from it to get us up and running. But this small part that you learn can take you a lot. You can do a lot with it. So just have a look at this. We have here a small configuration property. It's already in this. There is a little file here called. There are two files that you need to have. One is called glassfish-resources. Sorry, this screen is not helping me. Okay, and the other one is called persistence.xml. So in persistence.xml, there is this value here called drop and create. Database, schema, drop and create, yes. So what this is doing is every time I run my project, it drops and creates, okay? This is okay if you are in development environment. This is very good, because whenever you do changes, yes. In real life, you never do this, of course. You will comment this. Yes. Somebody can lose their job very easily if they do it. So we don't do this. By the way, you can also get the script that was generated. The script. Let us just try it very quickly here. So if I go to C drive, C, where is C drive? Here it is, C, glassfish, domains, domain 1, config. You see here the scripts. You can even generate the script that the JPA has generated to create the database. And this could be very useful also. So here is the script, just to have a look what's going on. In this case, it's very simple. It created a table, course code, course name, and primary key is course code. You see what's going on? That annotations we added helped the system to generate this script. And you can see it if you wish. Okay? That is the idea. So, and it's all driven by configuration. The configuration, of course, is not trivial. And again, you don't need to, it's nothing creative. You just need to read the documentation and do what they ask you to do if you wish to configure it. There is some default behave. If you don't do all of this, there is some default behave. Sorry, that, all right. Okay, so just to show you what in this persistent.xml, it has basically this configuration saying, I want you whenever you go ahead, you can also do it graphically. You can create this file graphically. It says here, table generation strategy. Drop and create, none, and so on, okay? That is the idea of this. All right, so that's basically the magic behind it. Let me move on here, sorry. Okay, here it is. Okay, this is my repository, as I mentioned. This is the find, okay? This is the add. I just do entitymanager.persist, and this will generate the insert statement. If I want to update, I use the merge, entitymanager.merge. If I want to delete, I showed you last time, you can read it, then do a remove. Or for me, I prefer to do it directly using a delete statement. So you are familiar with delete. Delete from course where the course code is equal, and this one is a parameter. So parameter is colon and the parameter name. And then before you execute it, you go and say query.setParameter. You pass the parameter and then you execute the update. Okay? This is how you do delete. To select all, this is how you do select all. Select from course, and then you call the method getResultList. This will give you the list of courses in and cast it to a list of courses of list of objects of type course. Okay. No, this one is a method provided by the Entitymanager. Okay? Yes. So have a look at this. So here in the Entitymanager, these are the methods that it provides, the major methods that it provides. Each one, what it does is discussed here. Okay? So to summarize, The way we use this JPA, we take our entity classes, we add the annotations, and we go ahead and generate, when we run it, we'll auto-generate the tables, and then we use the entity manager to read and write from the database. That's the basic idea. Now, yes, yes, please.
Question. So we have to introduce the request. يعني it will be, we will have class request and we will have an array list, for example, in the student of requests.
Yes.
Okay, and database, how it will be like visualized in this?
Okay, very good. Yeah, I will come to this. So the annotations I showed you are the basics.
I thought about this.
Sorry?
Foreign keys.
Yes, yes. Like through annotations, you can establish that one-to-many relationships or many-to-one. Yes, but you can join them. You can join them. You know, remember, like, we will come. That's what I'm jumping to immediately. So what I want to say here, if you want to learn JPA, you need to basically learn two things. The annotations that you need to learn, and second is the API of the entity manager, the methods that the entity manager provides. Sorry, and the third thing is this GPQL, which is similar to SQL. It's a language very, very similar to SQL. You don't feel too much difference. The ones I just showed you select from, these are GPQL. But if you look carefully, in here, this, if you take this and run it, it will not execute. I'll show you. If I take this one, it looks very similar to SQL. By the way, if you want to connect to your database, which brings me to another explanation. Remember I told you when you run your application, a database will get created. Okay? Now, Glassfish comes with a small built-in database called Derby. You can, of course, in real life use Oracle or use any other database, but I know you went through a lot of kind of challenges to get the Oracle running and get to work with it. So, but this one is you don't even see it if you don't want to. Okay, but sometimes you want to see it just for debugging or to see how things are moving. So what you do is you go to this tab. You see here I have a tab called Services. Okay, and have here something called Database. So whenever you run the application, you see this tab here. What does it say? Apache Derby is running and it's listening on this port 1527. Okay, so when you start Glassfish, what does it start automatically? The Derby database. Yes. So if I want to connect to it, I just do here new connection, and I will use JavaDB network, okay? Because whenever I want to connect to a database, I need to choose which driver I will use to connect to it. There are many drivers pre-installed. Oracle driver, we don't want to go there. We just stay with the simple one that does the same thing. It's very powerful. You can do all what you did in your 351, but a very, very simple database. So it comes into two versions. Either embedded. Embedded means you take the database and make it part of your application. It does not run separate. Or you can run the database as a separate server, and you connect to it. Okay? So in our case, we are using a networked version, not the embedded one. So here is the networked one, and I do next. Then I provide what is the name of the server, localhost. What is the port? 1527. Okay, 1527. What is the database name? ComDB. You remember that what is known? What is the glassfish resources.xml? In there we specify the database name, and I called it ComDB. So in here I'm connecting to it, and because it is, yes, in the configuration. I will show it to you shortly. Okay, and the username and password is app. Very secure. This is the default password and username. Remember it and test the connection. Hopefully, the connection is successful. And I finish. Once I finish, it shows me, here is the connection. And then if I click here, click app, tables, I see my course. And I see the schema. I see the schema there. And I see that there is an index there. There's no foreign key yet because there's no relationships. But later on, you can have foreign keys and all that stuff, all through annotations. Okay, now, if I want, I can do view data. And is there anything? Yes. There is nothing in there. There's nothing in there. Okay. Anyway, see that select I copied from the code. If I just run it, it will not work. It says here C is not a table. It's confused. How to fix it in SQL? .star. Okay, or I can put the column names. All right, this is fine. Although there's nothing in there yet. Okay, so JPQL is very, very similar to SQL. But if you wish to use SQL, you can also use SQL if you wish. So if you want to use SQL, sorry, here it is. Okay, sorry, here it is. Yeah, sorry, I will just answer this one. So if you want to use JPQL, you use create query. Okay, if you want to use SQL, you use create native query. My resolution. Okay, so in here you will use, this one is native SQL statement. If you want to use JPQL, you will use native query like this. Okay, so there are some slight differences between the two. Inshallah, next week we'll discuss them a little bit more on Sunday, but that will not stop you from moving. Your queries are very, very simple. Okay, if there is any complex one that you cannot do, just post a question on Piazza. I will help you do it. That's not the purpose of, because remember, SQL you should already know it from 351. That's not the challenge in this course. Okay, now in the remaining time, I will show you. Any questions so far? Sorry, you had a question? Okay. All right. The data, just I promised you that I'll show you where we specify the database name. In here. If you see here. Yeah, database name, ComDB. Okay. And also, that's basically the ID. Now, let me go back to the slides and just show you. I showed you before the basic annotation. This is the minimal. This is the minimal to get you off the ground, up and running. But if you happen to be with some administrator, not very helpful, they might kind of force you to name things the way they put some standards. You cannot do it the way you wish. No problem. You can still keep them happy and keep your program also the way the best standards that you believe in. So in here, you want to call this one ID, but the administrator doesn't like it. They want you to call it employee ID. No problem. So if you all agree, you just put the annotation, or that's it. But if you disagree on the names with the database administrator, no problem. You can add extra annotations, say column, and here employee ID. So in the table, this column will be referred to as employee ID. In your class, it is referred to as ID. You can also add extra annotations, whether you want it to be null or not null, the length, and so on. But if you don't, there is some default behave.
Is this for a primary key or for a regular column, the other line?
No. Here, what I'm trying to explain here is this column annotation.
Yes.
So the column annotation is used to change the configuration of the column. You can rename it. You can define whether it can be null or not null. You can define the length. Otherwise, by default, I think it's 255 characters by default. But you can change if you wish. Okay. Also for the table name, although you can do it this way, this is a long way, or you can just do it. This is even better here. So if you just put entity Your table will be employee, okay? But if you wish, you can customize the name by adding name between parentheses. That's basically the idea, okay? So this is the final example here, just to show you one more time. This is my table, and this is my class. And I'm mapping my class to my table. So because I'm putting here entity and not changing the name, so same name. This is the primary key, so here is the primary key, and so on. And then this column, I changed the name of this column. So instead of credit rating, it will be called credit. And on the table, it is called credit. Okay, that's it. Yep. Mm-hmm. Very good. This is a very good question. So if you use GPQL, you refer to the class name. If you use SQL, you use the table name. Are you following? So because JPQL, you are dealing with objects. You are querying objects. If you are using native SQL, you are querying tables. You are writing SQL against the tables. Okay? So that is the idea. So that's why it is encouraged to you really use GPQL as much as you can. Okay, one more thing. Once you understand the basic annotation, it's time now to move to the next step and learn how to map relationships. Because in database world, you cannot talk about any meaningful database without having relationships. And you already seen this in 351. You can have a one-to-many relationship, a many-to-one, a many-to-many, and so on. So here is an example. So just have a look at the tables first. This is an ER diagram, sophisticated one. So in terms of visualization, here is my customer table, and here is my order table. So how do I read this? Yes, so you see here one customer has many orders, and an order belongs to one customer, okay? So we call this one the many-side table, and we call this one the one-side table. How do we establish the relationship in the relational world? Yes, so we put the primary key of the one side as a foreign key in the many side. That's how we establish the relationship. Okay? Now, suppose I don't have this. I want to auto-generate it from my classes. Okay? So what I do, this is my class. So let's focus on this one. Here's my class. Let's say it has an ID, shipping address, whatever it might have. But basically, this is how it looks. This is an order. It has a customer. And what is the relationship? How do I read the relationship? Many to one. This is a many to one. It says it here. This is the many side, and this is the one side. How do I read it? A many to one. All I do, this is the many to one. Okay? If I just add this annotation, it will create this foreign key. But the name of the foreign key, by default, the name of the foreign key will be customer underscore order. This is the default name of the foreign key. But usually that name is not very suitable. So if I want to customize the foreign key, what do? I add an annotation here called join column and specify my custom name. That I don't want to have the default name that JPA generates. But if you don't put this, no problem. It will establish the relationship, but the foreign key will have a weird name that most likely not very meaningful. Definitely will upset the DBA. So to keep everybody happy, we do, this is the mandatory, the must-have annotation, and this is the optional one to customize the foreign key column. Sorry? Yes, many to one, yep, okay. Basically, if you wish, you can stop here. That's it. You establish a relationship, and you have a foreign key. But if you wish, you can make it a bi-directional relationship. You know, in the objects or relational world, we call this an association. It's just a terminology, or We call this an association. We also call this an association or even aggregation. Okay, we have one customer aggregates many orders. Okay, now if I want to make it bidirectional, what is the annotation? One to many. It's not many to one, one to many. So here I put the annotation one to many, and I will say to JPA, if you want to know more about this relationship, please refer to the annotation added to the customer attribute. So I'll do here one to many and say mapped by, and I put the attribute name of the many side. Let me summarize it one more time. So in the database world, we have this fundamental concept of relationships between entities. And to establish relationships, we use foreign keys. A foreign key is basically we take the primary key of the one side and we put it on the many side. Now, yes, sorry? As a foreign key, yes. So the primary key on the one side table becomes the foreign key on the many side table. Okay? Now we want to translate this knowledge, or we want to transfer this knowledge to the classes. Because classes, there is no such concept. There is a different concept, a little bit similar. We have the concept of association and aggregation. So what we want is we want to add some annotations to those associations and aggregations to map them to the concept of relationships in database. So depending on the meaning, so we know that a customer can have many orders. So the order is the many side. So I'll add this annotation many to one. So a customer can have many orders. So I do many to one. If I stop here, a foreign key will be created. And the foreign key name will be the table name underscore the one side table underscore the many side table. Most likely that's not very good name. You customize it using join column. Okay? If you just stop here, there is no problem that when you run your application, such relationship will be established. Now, if you wish to have it bidirectional, which means from customer you can get to orders, no problem, you can add this extra annotation, one to many, because a customer has many orders. And you don't need to repeat, you might have some configuration here, I'll explain shortly. You don't need to repeat it again. You just say, oh, by the way, this is a one to many, but if you want to know more about it, I'm not going to tell you and repeat myself. Go and refer to the customer attributes on the order class. Is clear? So, and it is up to you. What do you care about? If you care about this relationship, put the annotation for it. If you care about this relationship, put the annotation for it. You don't need to put both. It's up to you. You can put both. You can put only one of the relationships, no problem. By the way, unfortunately, I discovered if you put both and you try to serialize to JSON, it does not work, because this is called circular reference. This one referring to that and the other one referring to that, it upsets the JSON serializer. So, which is good. Let's keep it simple. So in your case, most likely you will have student, maybe student and override requests, and just add annotation in there, in the override requests. Okay. All right. So. Sorry. No, I will explain it. Just shortly, I will explain it. So what happens is, once you add these annotations, this is the power of this. If you read if you select an order, if you find an order, the customer will be auto-populated. Automatically will be filled. And if you read the customer, the orders will be automatically filled. Okay, but the difference is, if the property is a simple object, it will be filled immediately when you read the order. While in here, this one is a list, so there is a risk that this list will be big. So it will not be automatically filled until you read it, you access it the first time. Are you following? So it's a lot because this took a lot of years to develop. So this one is called eager fetching. Eager fetching means as soon as you read the order, it reads the customer immediately, like together as one hit, as one go. But this one is called lazy loading. It will only load the orders first time you access this property. But the good news, you can customize it if you wish. So by default, lists are lazy loaded, and the simple objects are eagerly loaded. But you can change this behavior. So in here, I can say fetch, I want it to be eager, even if the default is lazy. Okay. There's also another concept. Let's say if I update the customer, I also want to update the orders. I add this annotation here, cascade. Let's say if I add the customer, I want to add the orders associated with it. Or if I update the customer, I also want to update the orders associated with it. You can cascade the update. So these are more advanced, but just be aware of them. I don't think we will get there. This is the last annotation I will show you, a very, very useful one. And that's it, I'll let you go. Here is the contact. Have a look at this. So this is very common in object-oriented programming. I have a contact, and this contact has an address. So in database, this is definitely not allowed. You cannot have a column called address with multiple values. The normalization police will be chasing you everywhere. That's not allowed at all. Column must have simple value. Is clear? Now, in the object relational, this is very common. Very common to have an attribute that is a complex object. So how do I bridge the two worlds? So what I do, I make this class, I annotate it with this keyword embeddable, and when I use it inside another class, I annotate it with embedded. Then what will happen when I run? It will be one table. It will be one table, and that table will have ID, first name, last name, and so on. When it comes to the address, no, it will be street. Yeah, all the attributes will be there. So these attributes will be columns in the contact table. No, you cannot, because this one is one-to-one relationship. So this one, you're right. This one can be implemented either as a one-to-one relationship or as embeddable. One-to-one relationship will be two tables, but embedded will be one table. Is clear? No, multiple fields. Yeah. Yes. For example, have a look at this. This one is in the relational model. Sorry, in the object-oriented model, we have an employee has an employee period. So this is in the object-oriented world. In the database world, كلهم مع بعض in one table. Okay. Yes, it's flattened into one. How to do that? The small class you put embeddable, and when you use it in the big class you put embedded, and when it's created physically in the database, it will be put as one table. Okay. One query with two classes, yes. Very quickly here. By the way, the one that has all this stuff is this one. Just have a look. Very quickly, this JPA has what you are asking for. Have a look at this. This is my entities, customer and order. Okay. Here is a customer, and here is an order. Here is a customer, and here is the order. Can you see here the order one-to-many? Now, there is something called named query. Don't worry about it. It's just a query with a name. Or you can put it as a string in your code. It's up to you. So this is how it looks like. So what I'm doing here. So So what I want to do here, I am joining customer inner join orders, similar to SQL, inner join orders. I am filtering by customer ID and grouping by name. In this case, I just want to know for each customer how many orders they have placed. So, and I am creating a new class. Have a look at this. Name, I'm just interested on the name and the sum of the quantity. Okay. If this one is too complex, you can use SQL that you're already familiar with and use create named query instead of create query. And you can use SQL. Sorry? Oh, don't worry. This is not, if you need help with it, just put in Piazza what you need and I will help you to write the query. That's not a problem. Of course, a long time. It's there already. Yeah, it's there. All right, inshallah in the lab it will be much easier. Okay, thank you very much. Assalamu alaikum.
We need to look all of these folders.
No.
We need to understand all of them. For now, for this.
Yes. Basically, you have entities.
No, I mean here, the JPA, inheritance, join. Now we need to understand all of this.
Inheritance, no need.
Okay.
Even you don't need it even in your homework. But it's just for completeness. I'll be explaining it theoretically. But you need to know the one-to-many, many-to-one, the joins.
This document, I just focus on customer. Like this.
Yes, customer and order. So there is a customer and order. You can create a customer, add orders to the customer, and you can get a summary of the customer. Yeah. This one gives you a full picture. If you understand it, you can very easily do the homework.
There is no example in many-to-many. I want
A many-to-many, no.
So how to do it?
So I didn't provide a many-to-many example. No, we don't need many-to-many. Because basically you have student has overall